So number 2, part C, asked you to calculate the rotational inertia of the rod block system about the hinge. So we need the rotational inertia of the rod and the block together about the hinge, which is on the left end there. What they told you was that the rotational inertia of a rod about its center of mass, so right there, is 1/12 ml squared. So, okay, that's its rotational inertia about its center, but we need to know what it is about the hinge, which is on the end. What we can do is we can use the parallel axis theorem to get that. So the parallel axis theorem says that the rotational inertia of something about an axis parallel to an axis through its center of mass can be found this way. So rotational inertia about the parallel axis, which is an axis through the hinge, we can do rotational inertia about the axis through the center of mass, which we know, plus the mass of the whole thing times the distance between the two axes squared. So we're going to use that. So we know rotational inertia about the center of mass is 1/12 ml squared. And then the distance between the two axes is half the length of the rod, so L over 2, and we square that. And so we can use this to get the rotational inertia about the end, about the hinge for the rod. So if we square the L over 2, the 1/2 becomes a 1/4, and then we have L squared. And then 1/12 plus 1/4, if you work that out, is actually 1/3 ml squared. So that's the rotational inertia of the rod about its end, about the hinge. But then they want the rotational inertia of the rod block system. Rotational inertias add. So all we have to do to get the total rotational inertia for the system is add rotational inertia of the rod and rotational inertia of the block about the hinge. So we just found rotational inertia of the rod. I'm going to go ahead and plug in our actual values. So the mass of the rod, I think, is 2 kilograms. And then the length of the rod is 0.6. So that's my 1/3 ml squared. And then rotational inertia of the block, we can just treat the block as like a particle, a point mass. And the way you get that rotational inertia is just mr squared. So the mass of the block times the distance from the hinge, which is 0.6 squared. And that will give you the rotational inertia of the rod block system about the hinge.